So yeah, I'm Sergey, and I'm working at Toloka as a crowd solutions architect. So I'm basically a person who is designing these crowd pipelines, these solutions for your models. And tonight I'm gonna discuss with you a pretty popular case for e-commerce, which is product matching, and how to avoid possible pitfalls or find some insights. So, uh, why even bother with crowdsourcing? Imagine that you have an online marketplace, and every day different sellers come to you and bring their products for sale, and you have a database of some products, and you want to match the product that the person is going to sell at your marketplace with your database. So since this looks like a classification problem of whether the products match or not, you can apply machine learning techniques here. But to train a model, you need to provide it with pre-annotated examples. So, like, of examples of which is right, which is wrong, which is a match, which is a mismatch. But where do you get these answers? You need human expertise to answer these questions. And in the previous presentation, you've heard about control tasks, which are annotated by human experts. So you got your pre-annotated examples, but then another problem arises that product matching is actually not always straightforward, and there can be a lot of corner cases. And if you have a huge online marketplace, the volume of these matching tasks, the volume of incoming projects is very substantial. So you need to somehow scale your process, which in essence means that you can't rely on your very small pool of internal experts to do that. And this is where crowdsourcing comes in. So the task at hand is, again, you are given some products, some product information from a sellers, and you want to match them with your database. And the product info may feature an image of your product, some characteristics in a textual format, and there can also be some like vague description from the cell, which is just a text describing the product. And you want to find out if the product from the seller, again, matches the product from the database, which looks like a pairwise comparison. Just you make a task of a pair of products from the seller side and from your database side, and you treat it as a binary classification of whether it was a match or there was no match. And sometimes another problem arises that product info that comes from the seller may be inconsistent. For example, the product description may say that the product is blue, but in the image you can clearly see that the product at hand is white. It happens a lot, actually, especially with huge online marketplaces. So again, you have your input data, and you need to somehow compile it into an interface for your annotators to work with the task. So you, for example, this product info again may include the title, the image, some features, some aspects, and some tags, and you provide this pair of products to match. So what was our approach in this case? Again, the premise is that your annotators have to consider a lot of information confined within your title, image, and so on. So the task of just quickly answering whether it was a match or not becomes not so easy. And our solution in this case was to split this main global question, do these products match, into series of sub questions. Let me go back to, oh, well, let me just spoil the next slide a bit. So here is the interface for labeling. So our annotators had these two cards and the interface for labeling. And as you can see, there is no question about do these products match. We ask them a series of questions, whether the brands match, some colors of specific parts of the product. These were watches in this case, do like the band color matches, do the materials match, and so on. And the premise from our client was that just one mismatch in any aspect should result into an overall mismatch. So we deduced that when all the sub-questions gave us yes, whether these aspects match or not, this is a full match. And if just any sub-question was no, this is an overall mismatch. So we don't directly ask our annotators this binary question, but deduce it from the series of very direct and straightforward sub-questions. And since, again, there was a lot of information and the mismatch can happen in different parts in the title versus image, in the aspects versus the title, and so on, a very easy and quick tip. You can highlight some ideas from instructions in your annotating interface. The overall good guidelines is key, and you can you can highlight some information within your annotating interface, like you can see in the green frame at the top. So we encouraged our annotators to consider the tasks as a whole, compare pictures, product names, and make an estimate based on all of the available information. And here I mentioned that there can be contradictions in the seller's card, or even in the marketplace's card. There might have been some inconsistencies in the database. And we studied and control data really quick and found out together with our client that actually these cases were scarce. It was roughly about 5%. And we decided to add this question about whether there was any contradictions into the main project. However, that was an ad hoc choice, because if you are not sure about this distribution, it's always better to break your complicated task down into smaller subtasks, and they can be a pipeline of several consecutive projects, where, for example, you make a first project where you just ask about these contradictions, and you filter out any product cards with these contradictions, and only those cards that were consistent will be given for the main project of product matching. And for this project, we used a pipeline quite similar to the Alex's pipeline, which, as always in crowdsourcing, starts with just some wild crowd, which you want to filter according to some preliminary prerequisites. For example, since our particular task was in English, we added a filter that only the annotators that know English would have been able to work on the task. Then, when you get a relevant subset of your crowd performers, you provide them with a set of instructions. After they read your guidelines, your instructions, you give them training tasks, which is a set of tasks with correct answers and some explanations. which is when your annotator makes a mistake, they're shown a hint that explains how these tasks should have been labeled. Then, next step in the pipeline was the examination part. This is as the next step, which is available only for performers that pass to training, and there you just measure their accuracy. You don't provide them with any hints. You just give them a set of tasks with pre-annotated known answers and measure their accuracy, which is the percentage of the correct answers out of all the answers. And then the performers who went through this funnel, which again you saw in the previous project as well, where the annotators labeled the relevance. Then the annotators who passed through all of these sets of tasks are led into the main pool of tasks, and this is the step where your main data set comes in. But when your performers already work on your main data set, you still want to control the quality. And here you can mix in some control tasks into your main pool to keep measuring their accuracy. And there can even be some like a bit more advanced techniques, like when you get very reliable answers with high confidence from your performers, you can then add them to your next pool of tasks as the control ones. And also, well, making mistakes is humane. Your annotators might make mistakes even they are good and reliable, and you can make a separate set of rehabilitation tasks. Imagine that you have a good performer, but their quality drops, and you can send them to try to reread the instructions, try some exam tasks again, and give them an opportunity to increase their accuracy and be let into your main pool again. And then you get your results, and you can apply some aggregation models to tap into the wisdom of the crowd and say give one task to several performers, like 3, 5, so on, and aggregate their answers into one confident result. All right. So for this particular case, we actually found out some pitfalls. For example, since the description of these products is essentially a natural human language, there might be some ambiguity. There even might be some contextual synonyms. Like, for example, the seller might have described the color of the watch band as silver, and in your database they have it marked as stainless steel, but in the image you can clearly see that it's the same very color. Or like if we're talking about watches, sometimes the indices can be called just round index, or they can be named as dots, and somehow your task is to make your annotators think like you, like use their common sense and whatnot. And here you can add more examples into instructions, mention such corner cases. You can add these cases into your training and examination pools to explain these tricky parts. And also, well, just one more example of that. Sometimes we had products which is actually like only the watch head from the watch, so it's the head without the brand, and the client decided that you can't match just a part of the product to the complete product. So you have to track these corner cases as well. And the more diverse your data set is, the more diverse is your range of products, the more intricacies arise. And you can't add all of them into your examples and your guidelines. So like you have to give your annotators the most popular and representative corner cases to train them think like you, essentially. And the insights that we got from working on this project was, well, we proved the same thing that we keep talking about in all our tutorials, which is decomposition is key. And the project, this project proved it once again, because the data for labeling had to be very structured. We had to break this vague question of do these products match into a series of very straightforward and comprehensible sub-questions. We had to provide our performers with very step-by-step instructions, because as you could have seen, this interface is quite extensive and it might need a bit of an explanation of how to approach it. And again, we had to align our algorithm that we had in our head and represented in our instructions. We had to align everything reflected in our interface. And again, we needed to train our annotators and control their quality. And since my time is almost up, let me just summarize again. So if you are a marketplace, if you have an online marketplace, you actually have to match new incoming products to your database of products. You have to formalize the criteria of matching, because again, this question of do these products match is actually very vague, and you have to somehow break down, decompose the task to make it as clear as possible. You have to consider corner cases that will arise, and like Ilya mentioned, sometimes you can find some corner cases on the go. It's all right to start exploring with annotating. And again, like Evgenia said, you will be given some feedback from your annotators, and you absolutely must consider it, and maybe find some interesting and popular corner cases and tweak your instructions and control data set accordingly. And again, yeah, I just mentioned that you have to train and control the annotators to maintain a good quality.